A groundbreaking revelation in the cosmos. More celestial smash-ups involving black holes than ever before have been detected, causing a stir in the scientific community. Imagine a scene painted by an artist, depicting a cosmic hierarchy where black holes merge in a dance of the universe's most massive forces. This illustration captures the essence of recent discoveries made by researchers at the University of Portsmouth. Along with colleagues across the UK and an international team of scientists, these dedicated individuals have been studying the gravitational waves produced by the collisions of black holes and neutron stars. And their latest analysis has more than doubled the known number of such cosmic events from 90 to a staggering 218, with 128 new mergers identified. Black holes, though invisible to the naked eye, leave a telltale signature when they collide. They generate ripples in the fabric of space-time known as gravitational waves, which travel through the universe at the speed of light. Upon reaching Earth, these waves are incredibly small, smaller than 1/10,000th the width of a proton. Detecting such minuscule disturbances requires cutting-edge technology and highly sensitive instruments. The latest data analysis, published in the Gravitational-Wave Transient Catalog, GWTC 4.0, is based on observations collected from advanced detector collaborators from other UK institutions, including the Universities of Glasgow, Cardiff, Royal Holloway University of London, and Birmingham, contribute expertise in cosmology and astrophysics. The findings unveiled by the LIGO-Virgo-KAGRA collaboration cover the first 9 months of the fourth observing run, spanning May 2023 to January 2024. Professor Tessa Baker from the University of Portsmouth's Institute of Cosmology and Gravitation, who managed the cosmology paper in this release, expressed her excitement. After a period of relative quiet, it's thrilling to share over 100 new gravitational wave events with the public. These discoveries have enabled us to refine our understanding of the universe's expansion rate, the Hubble constant, a topic of intense debate among cosmologists today. Dr. Michael Williams, also from the University of Portsmouth, highlighted the scale of the GWTC-4 catalog. The volume of events in this catalog presented us with both a challenge and an opportunity. Coordinating the review and validation of these results demanded sustained collaboration, and I'm proud of the meticulousness and consistency we achieved throughout the process. Among the cataloged signals are 2 mergers between black holes and neutron stars. One of these, GW230529, was previously published, but the second, GW230518, is making its debut in this analysis release. The surge in detections is attributed to sensitivity enhancements made to the LIGO detectors since 2020. The UK has played a significant role in developing these detectors over the past 3 decades. Enhanced sensitivity allows for the detection of more sources and clearer measurements of gravitational wave signals. Notably, GW23014 stands as the strongest gravitational wave observation to date. Professor Ian Harry, a gravitational wave astronomy expert at the University of Portsmouth, elaborated. Gravitational wave signals provide the ultimate test for Einstein's theory of gravity. The stronger the signal, the more accurately we can measure any discrepancies. So far, Einstein's theory holds strong, but we'll continue to scrutinize it closely. To conduct these analyses effectively, it's crucial to have data from multiple gravitational wave detectors for cross-referencing purposes. As our dataset grows, we gain deeper insights into the fundamental aspects of the universe. The diverse range of mergers observed sheds new light on the evolution of stars throughout the universe's history. Dr. Greg Ashton of Royal Holloway University of London likened the study of black holes and neutron stars to paleontology. Just as paleontologists learn about extinct dinosaurs from fossilized remains, we can uncover secrets about stars by examining their black hole or neutron star remnants. In GWTC 4.0, we found intriguing evidence suggesting that some of the black holes detected may themselves be the product of previous mergers. Distinguishing between black holes formed from collapsing stars and those resulting from prior collisions will reveal more about stellar life cycles and their distribution across the cosmos. The University of Portsmouth's Institute of Cosmology and Gravitation, ICG, is a hub of research excellence. Home to over 70 researchers, faculty members, postdoctoral fellows, and PhD students who delve into the universe's deepest mysteries. From the aftermath of the Big Bang to the structure of galaxies, dark energy, and gravitational waves, the ICG's work is of global significance. Its research was unanimously recognized as world-leading or internationally excellent in the Research Excellence Framework, REF 2021. The ICG contributes to major international projects such as Euclid, LISA, Laser Interferometer Space Antenna, the LIGO Gravitational-Wave detectors, and the Dark Energy Spectroscopic Instrument, DESI.